Hunt for Planet X and Oort cloud sanctuary. Huge planets may be lurking on the outskirts of our solar system. Our solar system has had a chaotic past. The Earth and other planets are now in stable orbits, but there were drastic changes during their formation. Jupiter was probably much closer to the Sun than it is now, and its displacement not only moved other planets but also cleared the solar system of debris, throwing most of this into the Oort cloud. The Oort cloud is at the gravitational edge of our solar system. While most of the debris from the Oort cloud is likely relatively small, it's possible that planet-sized objects even more distant than the hypothetical Planet X Nibiru are lurking there. In recent years, astronomers have begun to actively study the Oort cloud in search of the mysterious Planet X, hints of the existence of which were discovered in the middle of the last decade. Some of the debris ejected from the inner solar system was likely thrown even further away, and they escaped the sun's gravity and were left to drift through interstellar space. We know this is possible because we have had at least 2 cometary guests from other star systems. We've also observed rogue planets that have broken gravitational bonds with their parent star. There are many celestial orphans in the galaxy. But it also raises the interesting question, if a young planetary system can push back comets and planets, could other star systems take over some of these worlds? This is the subject of a new paper accepted for publication in the monthly notices of the Royal Astronomical Society, available on our ARXIV preprint server. The team of scientists ran a series of computer simulations studying how planetary systems kick off large planets and how a planetary system can catch one. In order to be ejected, a planet must gain enough kinetic energy to get out of its star's gravitational pull, but it also means that the planet has so much kinetic energy that it would be difficult for another star system to hold on to it. And as with the visits of interstellar comets Umama and Borisov, most celestial encounters with the rogue planet would have been fleeting. But the team found that the gravitational pull of the galaxy itself can dampen the motion of the rogue planet, and thus in a small fraction of celestial collisions, the star can trap the planet. The best chance for this is not when the planet passes close to the star, but rather when it drifts directly inside the Oort cloud. Most of the planets captured by the star will be on the outer edge of the system. Our calculations show that planets that formed inside the chaotically arranged Oort cloud or fell into it from the outside can exist inside it for billions of years. This suggests that large exoworlds should often be found in such regions of planetary systems. If such a planet exists inside our solar system, then it's removed from the hypothetical Planet X by tens or hundreds of times, the researchers write. And according to calculations, up to 10% of the star's original planets could have been ejected into deep space. Given the dynamics of the galaxy and their early solar system, there's about a 7% chance that the solar system has a trapped icy giant planet in the Oort cloud. But the probability that an ice giant formed in the solar system was forced into the Oort cloud is about 1 chance in 200. Thus, if there is a planet at the edge of the solar system, then most likely it is an adopted child and not one from the offspring of our sun. Of course, it's most likely that there are no large worlds in the Oort cloud, but this study shows that planetary systems do not always form in isolation, and there are many star systems that are likely to be mixed families. This is on Solask. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.